Hello everyone. This video lecture is about how to develop and model for AM modulation in Simulink. So let us understand first the problem statement. Here we need to apply the concept of AM to generate and detect AM signals using MATLAB Simulink. Okay. So we already know that AM signal is having this as the standard equation. Okay. Now let us assume AC is equal to 2 volt, mu 0.5, FM signal 40 Hz, whereas FC is 1500 Hz. Using these values in the above equation here, we can rewrite the equation as 2 into 1 plus 0.5 cos 2 pi 40t multiplied by cos 2 pi 1500t. Now simplifying this, that is multiplying this 2 into the brackets, we can write 2 plus cos 2 pi 40t multiplied by cos 2 pi 1500t. So this is the exact equation which we are going to represent in Simulink model. So with this equation, I have designed a block diagram here. You can see we have a message signal, then carrier signal. Message signal added with 2 is multiplied with the carrier signal. Resultant is our AM signal. And we have spectrum analyzers placed at every signal, that is at message, carrier, then modulated signal here, and then after demodulation. Okay. Now let us build this model using MATLAB Simulink. Okay. Once you open MATLAB, you have to click on Home. Then you have to click on Simulink library here. You will get this window. Some PCs might take 1 or 2 minutes time to load this window. Once it is loaded, you have to click on New Model, which is at the leftmost corner. Now your workspace is ready. Let me minimize this. So to build this model, we need to place the required blocks and interconnect them and configure and then run the program. Okay, so let us do that now. The first thing needs to be noted is we need to click on library browser. Here we need to search for sine block because our first block was sine there. Okay, so this is the one we need to choose. It is not sine wave function. We are looking for sine wave. Let me add it to untitled and you can see it is been added. Let me copy this now. So I have got 2 sine. I can change the name by clicking here and typing. Okay, so this is my message signal. This is the carrier. Okay, now next block we have is constant, then adder, then product model. So let us search for the constant. Yes, this is constant. Let me add. Next is product. So this is the block which is required. Right click and then add to untitled. Similarly, we want a summer. So just type sum and enter. You will get summer, add to untitled. Then we also want scope to visualize time domain waveforms. Search for it, add to untitled. Then to visualize the spectrum of the signal, we need to have spectrum analyzer and zero order hold. Okay, so let me add it to the untitled. So this is the modulation part. So first we'll complete that. When I go to untitled, you can see that all the blocks are here. Okay, so we can separate them out. So this is zero order hold and spectrum analyzer. They are work in coordination. That's why we'll place them at the end. Then scope. Then we have summer. Then the product and the constant. As indicated in the equation, message signal should be added with a constant value of 2, that is our AC. So let me frame it as 2. Then carrier should be multiplied with message signal summed with 2. Finally, we'll get the output. Okay, so now we need to have zero order hold and spectrum analyzer for message signal, carrier signal, as well as for the modulated AM signal. So for that, let us copy. Before copying, let me type the sample time, which should be as small as possible. Okay, so we can place it for message as well as for the carrier, and then for the final output. Okay, so now we need to configure message signal. That is, our required amplitude was 1, frequency was 2 star pi 40, right? And phase we are using as 90 because we have used a cosine signal. If phase is 0, then it will be sine. Okay, this is set now. No need to change anything else, only these parameters. Now again go to carrier signal and we need to repeat the procedure here. Since AC amplitude I have already multiplied, I can directly write amplitude as 1 for this carrier signal and frequency 2 pi 1500 and phase again it is 90. Okay, then constant I have already set. Now zero order hold also I have set. Okay, similarly zero order hold for the carrier signal, then it is given to spectrum analyzer. Okay, let me maximize it. So this is the AM generator circuit, we can say, our block diagram representation we can see. Now this scope is showing only output, but we need to have 3 outputs, that is message signal also we want to know, carrier signal also we want to know, along with the final output. So let me change its configuration. Double click, go to this setting option. Here axis is 1, let me change it to 3. So 3 scopes we can simultaneously visualize. Okay, so this should be our carrier signal, first message, then carrier, then output. Okay, now we can run this program. So as you can see, this is the message spectrum, where if you see at the bottom, it is near to 0, which is minus 40 hertz, you can say, and plus 40 hertz. So peak is at minus 40 hertz and plus 40 hertz. Okay, this is the spectrum of message signal. Now let us look at the spectrum of carrier signal. So this is the carrier signal spectrum, which is centered around 1.5 kilohertz. This scale is in kilohertz, so 1.5 kilohertz plus 1.5 kilohertz and minus 1.5 kilohertz. So this is our carrier signals spectrum. Now as you can observe, the message frequency has been shifted around 1.5 kilohertz. This is our carrier signal, whereas this one is upper sideband, this is the lower sideband. Same is true in the negative frequency region as well. Okay, so now let us look at the time domain waveforms. Okay, as you can see, this is our low frequency message signal and this is the high frequency carrier, and when we modulate it, we get the AM signal like this here. Okay, so you can observe that AM modulation. Now next, as we know from the circuit, we need to build the demodulator. Here, this part, it is from here constant 0, switch, analog filter. This part constitutes an envelope detector. So we want a switch means we need to search and add it to the untitled. Analog filter design, add to untitled, then constant we have, that only we can copy. Okay, now let me copy the constant, which is, double click and change it to 0. Okay, then output of the product should be connected to two inputs, that is these two top inputs. Then finally we have to connect the resultant to filter with configuration C. Filter order is 8 and frequency which it has to pass is 2 pi 40. So this is a low pass filter. Now let us take a scope. I am copying this scope. Okay, so this is my output, and we want to compare this final output with our message signal, so I am giving it here. Okay, apart from that, I want only two scopes, so axis is 3, but I will change it to 2. Okay, yes, this is our output scope. Now we also need to know what is the spectrum after demodulate. That's why I'm copying this zero order hold and spectrum analyzer, and we'll place it over here. Okay, so let us run this program now. So this is message spectrum as we discussed earlier. Then we have the carrier, then this is modulated signal. Now this part we want to bring it back to origin, that is our baseband region, right? So let us see whether we are able to achieve this. Yes, we have achieved, but there is a distortion, that is DC level, which is appearing here, which was absent in the message signal. You can see here positive frequency 40 hertz, negative minus 40 hertz, but the DC level was 0. At DC voltage it was very small value, whereas here we are getting a DC voltage which we can remove in the further processing. Okay, but we are successfully demodulated, that is our spectrum has been shifted from 1.5k to 0, that is around 0, which is 40 Hz and minus 40 Hz, the baseband region. Okay, let us now examine the time domain waveforms, whether it is correct or not. So you can observe that there is a difference in the amplitude, okay, but the frequency of the signal is same. There is a delay also, but the frequency of the signal is almost same. So we are able to reconstruct back our signal after modulating it using AM modulation technique. This is our receiver part, whereas this is our transmitter part. Okay, I hope you have understood this. Thanks for watching.